Today, in section 9.3, our objective is to solve quadratics by graphing. So I don't know if you remember when we were solving systems of equation by graphing, how difficult that was. If you remember, you graph two lines, you're trying to find this point graphically. Usually what we do by graphing is very important, but usually solving things by graphing can be very difficult. So let's go back. What does it mean to solve something? Well, remember, a solution for a quadratic is the same as the roots, which is the same as the zeros, which graphically are the x-intercepts. So sometimes they might hit perfectly. Other times we might have to approximate. Here's that parabola from the previous lesson. We have no idea where this is crossing the x-axis. So right here and right here would be the roots, the zeros, the solutions. Who knows what that is, right? Who knows? Okay, but sometimes it does turn out okay, and it is important for us to know how to find this from a graph. Alrighty, so starting from the standard form of a quadratic, which remember is y equals ax squared plus bx plus c, if we can change this equation, into what's called intercept form. So last time I alluded that there were different forms. So now we have the intercept form of a quadratic, and you will be responsible to know this. Y is equal to a times the quantity x minus p times x minus q. Looks very much like it got factored, right? And that's exactly what happened. That's called the intercept form. Well, the intercepts are great because those are the same as the solutions, the p and the q. All right, so here are the steps to solve by graphing. If you can, factor your quadratic and write it in intercept form. So we're just going to jump in and do that for this right here. Here's our quadratic equation. Y is equal to x squared minus 2x minus 3. I'm going to try and factor this. So I put down my two parentheses. I've got a negative sign here. That means one is plus and one is minus. I need two numbers to multiply to 3, but have a difference of, or a sum of -2, or they have a difference of 2. So that's going to be a -3 and a +1. So I have just rewritten this is in standard form, and I rewrote this in intercept form. From intercept form, it becomes kind of cool how we graph it. We know if x plus 1 is a factor, then x equals -1 is a root, or shortcut, you just take the opposite of this. So -1 is going to be an x-intercept. And our other intercept would be the opposite of this, or +3, 1, 2, 3. I hope this is clear how I got these 2 points from this. Algebraically, if we set this equal to 0, x equals -1 is a 0. Remember, the 0 is the same as the x-intercepts. So there's an x-intercept, there's an x-intercept. Now, where the heck is the vertex? Well, we know from symmetry the vertex is going to be halfway between the two intercepts. Does that make sense? So we count. We've got 1, 2, 3, 4. So 1, 2, here's my vertex. It's going to be somewhere along here. Here's my axis of symmetry. But where is my vertex, right? Well, what's the x-coordinate of the vertex? The x-coordinate is 1. And so I can figure this out when x equals 1. That will give me my vertex. So I could either put it in here, x equals 1, and then put it in here. So if x equals 1, we would have 2, 1 minus 3 is -2, or a -4. So when x equals 1, y equals -4. 1, 2, 3, 4. And we don't even have to look at our A rule of 1 for this. I've got my 2 intercepts, I've got my vertex, so I can sketch a graph from intercept form. That's not too bad. Solving it, then we know that our solutions are the same as the intercepts. So x equals -1 and x equals 3 are my solutions. So again, the solutions, very important point, are the same as the x-intercepts. The solutions are the same as the x-intercepts of a graph. So if you are given the graph, you should be able to find the solutions. If you're given the solutions, you should be able to sketch a graph. Going back here, if you can't factor, then we have to do a little bit more finagling. That will come up. All right, example 2, convert to intercept form, sketch a graph, labeling the roots and the vertex. All right, so here we go. Can we factor this? Going back and using the methods that we used previously, whenever you have a negative out front, let's pull that off. So you have x squared minus 2x plus 1. Factor this. This sign is a positive. That means these two signs are the same. This is negative. That means they're both negative. So we have x minus 1 and x minus 1. And I have a negative out front. All right, let's sketch a graph of this. If x minus 1 is a factor, then x equals 1 would be a root. This is how I'm solving that. Root, factor. Notice that the sign is opposite. So I go over here to x equals 1, and that's a root or an x-intercept. I'm going to get a double. It's the same here. Ooh, that's strange. Well, what this means is that our parabola touches just at one time. It's either going to go down or it's going to go up. Well, this is the vertex, so I'm not going to do my halfway between. So then I'm just going to go back and use all the tools in the tool belt, everything that we've learned so far about quadratics. I'm going to go back up here to my standard form, and I'm going to see that the A is a -1. So I can sketch my graph from that. So here's my vertex. If I go 1 to the right, I'm going to go down 1. If I go 1 to the left, I'm going to go down 1. And my parabola would look like this. Notice our C, our y-intercept. So we keep adding on, more and more about parabolas. We can use anything at any time. What are my solutions? I only have one solution. That's at x equals 1. The fundamental theorem of algebra says a degree 2 must have 2 solutions. This is called a double root. A double root. X equals 1 twice. All right, let's go on. Let's do another one. Example 3. Y is equal to x squared minus 4x plus 7. We want to solve this by graphing. Well, remember step 1. If you can you write that in intercept form? Well, already I'm running through the numbers in my head. What are the factors of 7? Only 7 and 1. Are they going to add up to or have a difference of 4? No. So this cannot be factored. So writing it in intercept form is out. So then how would we graph this? Well, we have to go back to our previous methods of graphing and say, all right, my vertex is going to be found x is equal to negative b over 2a. Negative b would be a positive 4 all over 2 times 1 is 2. 4 divided by 2 is 2. What's y equal to? Y is equal to 2 squared minus 4 times 2 plus 7. 4 minus 8 plus 7. 11 minus 8 is equal to 3. So my vertex is the point 2, 3. One, two, 1, 2. Oh, I gotta go like this. Okay, 2, 3. 1, 2, 3. There's my vertex. My A is 1. So if I go to the right 1 and up 1, and to the left 1 and up 1, here's my parabola. All right, what are the solutions? Are there any x-intercepts? The answer is no. So this parabola has no solutions. And actually, I say no solutions. We're going to learn in a couple of days that there are solutions, but they're called imaginary numbers. Don't worry about that just yet. It has no, I should say, real solutions. No real solutions. It does not cross the x-axis. No real solutions. All right, let's try one more. Solve by graphing. Can you factor 8 into 2 numbers that add up to 6? This is a plus, so it means both these signs are the same. This is a minus, that means they're both minus. So 4 and 2, I can factor. Alrighty. So that means my 2 intercepts will be at x equals 4 and x equals 2. So let's graph this. 1, 2, 3, 4. 1, 2, 3, 4. So x equals 4, x equals 2. What's halfway between? That's where my vertex is. So you could add those together and divide by 2. We're going to get x equals 3. I'm trying to find my vertex. When x equals 3, what's the value of y? So y will be 3 squared minus 6 times 3 plus 8. 9 minus 18 plus 8. That's equal to a negative 1. So my vertex is the point 3, negative 1. 3, negative 1. I'm graphing this using the intercept form. It's just another way. Or I could use my C, right? 1, 2, 3, 4, 5, 6, 7, 8. If I wanted to, it's going to cross there. Kind of gives me a better picture. What are my solutions? My solutions are the same as the x-intercepts, which we had right back here. X equals 4 and x equals 2 are the zeros, the roots, the solutions. So we're doing 2 things here. Hard to break it down, but you should be able to change from standard to intercept form, graph from the intercept form, and also from the graph, recognize where are your solutions. And remember, sometimes they don't cross exactly at a number, and if they don't, then you just have to estimate. And that's our last problem here. If you have patience with me, let's try one more. Okay, can you factor this? You're going to have factors of 1 that are going to add up to 4. that doesn't work. So it cannot be factored. If it can't be factored, then we have to go back and use the x equals negative b over 2a. So our vertex, the x-coordinate, is going to be at negative 4 all over 2 times 1, or negative 2. The y, when x equals negative 2, don't forget your parentheses. Negative 2 quantity squared is positive 4. Minus 8 plus 1 gives us 5 minus 8, or negative 3. So let's sketch a graph. Where am I? I'm at negative 2, negative 3. Okay, negative 2, negative 3 right here. My a is 1, so over 1, up 1, over 1, up 1. Yee. Oh, I could have used my c, as this is actually gonna cross right there, right? So where are my roots? My roots, this is the roughest of rough graphs. You guys could use graph paper. But this parabola, do you see how I use the c? This parabola is going to cross between 0 and negative 1. So we're going to approximate x is between 0 and negative 1. That's where one root is. So if our vertex was at negative 2 and the root was between 0 and negative 1, where do you think this root is going to lie? Well, we were like 1.5 away, so go 1.5 here. This is negative 2, negative 3, and negative 4. So the other root would be between negative 3, negative 4. That's all that we can do for now. There are other methods where we can solve this exactly. That's coming up in a couple of days. All right, hope you're doing great.